So you want to do something like x plus 1 and x minus 3 are factors of f of x equals x cubed plus bx plus c. Use the factor theorem to find the values of b and c. Well, the first thing to say is that I've given details on the factor theorem in a previous video, so if you want to go back and find that, that might be helpful. But what I'm going to say here is that if x plus 1 is a factor of our f of x, and we're told that it is, then f of minus 1 equals 0. So I've taken this and reversed its sign. And by the same token, if x minus 3 is a factor of our f of x, and we're told it is again, then f of positive 3 equals 0. I've taken this, I've reversed its sign. And what this does, my knowledge of the factor theorem, helps me to form two helpful equations, simultaneous equations. If I know that f of minus 1 equals 0, then I can write this, f of minus 1. And f of minus 1 just means that I go through the function and I replace the x. Every time I see an x, I replace it with minus 1. So I do f of minus 1, so that's minus 1 cubed plus b times minus 1 plus c, and I know it equals 0 by the factor theorem. So I can tidy that up. Minus 1 cubed is minus times a minus is positive. Positive times a minus is a minus, so it's negative. And 1 times 1 times 1 is 1. Minus 1. Plus times a minus here. Plus times a minus is a minus 1b. So a minus b plus c equals 0. And I have what I might call equation 1. And then if we do the same here with x minus 3 as a factor, so we know that f of 3 equals 0. Well, f of 3, again, that's just going through this function and replacing x this time with 3. Every time I see x, replace it with 3. So that's 3 cubed plus b times 3 plus c equals 0. And if I tidy this one up as well, 3 cubed, 3 times 3 times 3 is 27 plus 3b plus c, and I know that equals 0 because of the factor theorem. And that gives me an equation 2. So you can see now that I've got two equations, and because I've got two equations, I can find two unknowns, b and c. And because I know that 0 equals minus 1 minus b plus c, and 0 also equals 27 plus 3b plus c, then I can write this. I can write minus 1 minus b plus c equals 27 plus 3b plus c, because on both sides that equals 0 and that equals 0, so they equal each other. And then I just need to do some tidying up. Now if I've got the same term on both sides of an equal sign, like I have here, I've got a plus c there and a plus c there, and just cancel them. So I'm left with minus 1 minus b equals 27 plus 3b. And then by the rules of the manipulation of algebraic equations, I can say that I've got a plus 3b here, I've got a minus b here. If I bring that minus b across, it'll become a positive b. So I've got 3b plus b on that side, and that equals, and I've got minus 1, and if I bring this across from being positive 27 there, it's just going to become negative 27. So minus 1 minus 27. So I've got minus 28 equals 3b plus b is 4b. And so I have b equals minus 28 over 4, and b equals minus 7. b equals minus 7. So I've got b, I know what b is, it's minus 7. And now because I know b, I can substitute b equals minus 7 into, and I can choose an equation. I'm going to choose this one, equation 1. I could choose equation 2 if I wanted, it would give me the same answer. This might be simpler. So substitute b equals minus 7 into equation 1. And if I do that, I've got minus 1 minus my b, which is minus 7, plus c equals 0. And hopefully that's going to help me to find c. So I've got minus 1, and your minus minus here is just going to give me a positive 7 plus c equals 0. and I've got minus 1 plus 7, that's going to give me 6. So 6 plus c equals 0. And therefore we got c equals minus 6. So I found b, I found c, and now the thing to do for completeness is just to write f of x equals, and now I'm going to rewrite this with the things that I now know. So I've got x cubed plus bx, and b is minus 7. So minus 7x, and I've got plus c, which is minus 6. So if I tidy that out, I've got x cubed minus 7x minus 6. So there we go.